I'm a photographer myself, documentary photographer. That was my career technically.
Really?
But
You had a career in photography?
yeah, well, I still sort of do. But
Really?
yeah.
So, thank you. So, career in photography, do you want to talk about that briefly?
No.
New York City kind of thing? Or,
I used to live in New York City.
Really?
Yeah.
Another time, perhaps?
Yeah.
So let's talk about the tea.
All right, so
Thank
so I was just saying that we've been in permaculture for a while, and now we're kind of over the winter we really dived a lot deeper. We found this scientist, Elaine Ingham, who lives in Oregon and have for I think her whole career been studying the microbes in the soil, and was the first one, together with her husband, who came up with discovering the relationship between the roots of the plant and the microbes in the soil, and how that all acts together, and how to use that then to grow healthy plants, and that's called the Soil Food Web, and she has now created this school called the Soil Food Web, which is an international school. So I'm doing the Soil Food Web consulting education, and part of it is that you learn how to make this compost, not kind of what people traditionally think is compost, where you just kind of pile it up in a pile and leave it. This is aerated compost. It has to be monitored with thermometer. It has to be turned at the right time, and you have to also you use a microscope to make sure that what the microbes you are growing are beneficials and at the right ratios, that you have. And then when you have that kind of compost, and it's very hard, it's not easy to, we're just now starting to get there, after this, we're just mixed our 8th compost pile the other day. And then you take some of that compost, put it in these specific tea bags, and then you, again with a very aerated, so you have to have air pumps coming in. Then you, over 24 hours, you can then brew these organisms. You take, the smaller quantity, and then you can multiply them by many.
By aerating them.
By air, but they need air, because all the good guys need air.
Air, right.
And then again, you check it with your microscope, so you know that what you actually were brewing and duplicating is actually good stuff. So you need to know how to identify things under the microscope. But of course, you check the compost before also you put it in under the microscope. So it's a scientific way of doing this, but that means you end up with results that can, where we can grow food. This is the whole point of it, is that we can grow food without any chemicals, without any artificial fertilizers, without, and it can take care of all the diseases, our pest issues, our weed issues, and we end up growing topsoil. So right now, most of the soil around the globe has been damaged because of our agricultural practices, so that when you look at the soil under the microscope, it's pretty much dead in terms of, of course there's life, there's bacteria, but there's nothing else in there. And that bacteria, and often that bacteria is anaerobic bacteria, not helpful bacteria, diseases, things like that. And the soil has been collapsed, so compacted, there's no air, and your plants need air. So when you get the soil food web back into the soil, you can take this, out of the compost tea and the compost, inoculate it back into the soil. Then you can, if you do it all right, within one growing season, you can take what is now we consider dirt, like dead soil, and bring it back to life. And that means bringing the fertility back to the soil. It means bringing the structure back so that your roots of your plants can go many, many feet deep into the soil. And with the fungal networks, the mycelium, also go very, very deep. We can store all the carbon that we need out of the atmosphere back into the soil where it belongs and where it does good. And we can reverse climate change. So this is like amazing. We end up with, so what happens is that when you have soil that doesn't have fungi, which most of the soil in the world today doesn't. I mean, if you go into the woods, of course you will have fungi, but you probably still have, like, this is not old forest. If you look at it under the microscope, you'll probably find that you have less fungi than these trees actually would be happy with, you know, because it takes an awful long time for nature to build the soil back up to what it was originally, and where you have then the fertility and the immune system of the planet. So what we're standing on right now, which this is a compacted road, so but if it wasn't that, you know, the soil underneath our feet, you know, is alive. It should be alive. It is billions and trillions and, you know, mega whatever. It's organisms, and this is the foundation of life on this planet. You know, without these guys, we can't really be here, and we don't understand that. We're starting to understand that, but it's still kind of new in agriculture, all of this. But I believe it's the way forward, and the amazing thing about it is that when you have the fungi in the soil, and you pour water or nitrogen or anything through, it all gets absorbed. It doesn't drain out. So this means you have drought resistance, you don't leach out your nutrients, so you don't end up with having you know, nitrates in your drinking water or in your lakes or, you know, places where you don't want it. You don't need all the chemicals again, so you don't kill all the wildlife, you don't make us sick and get cancer, and, you know, like all the bad stuff that we're doing right now. We could deal with that just by working with the biology. So it's very inspiring.